Hello everyone, so today we will solve problem from chapter 8, open channel. Problem number 1. A rectangular open channel is designed to convey 3000 liters per second of water. The roughness coefficient of the material of the channel is 0.034 to be laid on a slope of 0.0023. What should be the dimensions for the most efficient cross-section of the rectangular channel? So in this problem, we are tasked to solve for the dimensions of the rectangular channel, which is the base and the depth of this given figure. So for our given, we have here the roughness coefficient of 0.034, the slope of 0.0023, and the discharge, which is equal to 3000 liters per second. Converted to cubic meter, we will get 3 cubic meter per second. So for our solution, we have here the formula for discharge is equals to Q equal to area times the velocity. Since uniform steady flow, we can use the velocity from Manning's formula. So we will have now discharge Q is equals to A times the 1 all over roughness coefficient times the hydraulic radius raised to 2/3 times the slope raised to 1/2, which will serve as our equation 1. Since we have a rectangular channel, the base will be equal to twice the depth of the channel, and our hydraulic radius will be equal to d all over 2. And for our area, we will have base times depth. So for our solution, we will have to substitute all the values to equation 1. So for our equation 1, we have here the discharge is equals to area times 1 all over the roughness coefficient times the hydraulic radius raised to 2/3 times the slope raised to 1/2. It will be equal to 3 cubic meter per second is equals to the area, which is BD, multiplied to 1 all over 0.034, which is the roughness coefficient, multiplied to d over 2, which is our hydraulic radius raised to 2/3, and our slope of 0.0023 raised to 1/2. So given that b is equals to 2d, we will get 3 cubic meter per second is equals to 2d squared multiplied to 1 all over 0.034 times d over 2 raised to 2/3 times 0.0023 raised to 1/2. So computing this, we will get the value of d, or the depth, is equals to 1.217 meters. Now that we have the value of the one dimension, which is a d, we can now substitute the value of d to equation 2. Now that we have the value of one dimension, which is the depth, or d, is equals to 1.217 meter, we can now substitute this value to equation 2. So for our equation 2, we have base is equals to 2 times the depth, wherein our depth is equals to 1.217 meter. So substituting the value of d, we have here base is equals to 2 times 1.217 meter. And we will get the value of our base, or b, is equals to 2.434 meters. So the dimensions of our rectangular channel is equals to d is equals to 1.217 meter and b is equals to 2.434 meters.